This is video 19 in the series of reinforced concrete slabs. This video will deal with the special cases in the strip method. Consider a rectangular slab which is clamped on two sides or fixed on two sides and simply supported on two other sides. Of course, with the condition that B must be between the A and 2A, otherwise it will be a one-way slab instead of a two-way slab. When we look at the yield lines, we know that in this corner this angle is 30 and it's 60 degrees, the other corner 2 times 45 degrees, then 30 and 60 degrees again, and this, because of symmetry, it's 45 degrees. So when we have drawn the yield lines, we can now determine the geometrical quantities to calculate S2, the distance S2 in function of A and B. It is quite simple. We use the formula for triangles, which is the side A divided by the sum of the cotangens of the two corners. That gives you S2, like this mentioned here. So S2 is 0.366A. We do the same for S1, which is 0.634A, and then the distance S2 here, and then this distance is of course the same because of the 45 degrees. The same happens here. The distance S1 is the same as this distance S1 because of the angle of 45 degrees. Now we will choose a width of an horizontal and vertical strips. We have seen that we should take something like 2/3 of S1, which is 0.42A, so we round it off to 0.45A. And the 2/3 of S2 is 0.24A. We round it off to make it life easy to 0.2A, 0.20A. And the vertical strips, we do a similar thing like that. Instead of 5/6 of S1, we take 0.55A, and instead of 5/6 S2, we take 0.3 of A. So in a summary, the widths here are indicated the widths of the different strips, and then on the others, in the other direction, also the different values. So we have rounded off those figures to make it easy for us. And we take, of course, the length B, we take it equals as beta A. So the slab is now divided into zones, different zones. We have determined the dimensions of the zones. And now we can start calculating the reinforcement for each zone. The vertical reinforcement will be placed in the zones and identified here. In the middle, it will be continuous, and then there and there, that are the zones. And in horizontal direction, this will be the zones that we will use. So for zone 1, it's a simple case. It's fixed on one side and simply supported on the other, and the load is Q, the total load. And with the help of the known formulas for applied mechanics, we can calculate the sagging and the hogging bending moment and convert it into reinforcement. For the zone 3, we've seen here that there is Q, the value of Q is transferred in this zone and in this zone. So you have the two zones, and again, with traditional formulas from applied mechanics, we will calculate the bending moments and the reinforcement. For strip number 4 or section number 4, you see here the double arrow. Half of it is carried in this way, that we already got in the cross section running from in the vertical sense, that we already took. And now only what's left is half of it, so in this direction and half in this direction. That's why it's Q over 2.